Alright, good day everyone. Today we are going to talk about distance, displacement, their differences, their definitions, distance time graph, and also displacement time graph. Distance is just a measure of separations between 2 points. A distance is just a scalar quantity that has no direction but a magnitude. The magnitude of the distance depends on how far the distance is. Specifically, it doesn't have direction. Distance is just a quantity that has a symbol S representing a distance. So many students think we use D to represent a distance, but not. Distance never used to represent, or D never used to represent a distance, but we use S to represent a distance. The system international unit of distance is always meter. So distance and length has the same unit as meter. A very short distance is what is called a length, while a very long length is what is called a distance. Example of a distance, like the journey from Kano to Kaduna, from Kaduna to Abuja, from Nigeria to America. All these ones are distances, irrespective with where Kaduna, Abuja, and America are located. But this is what is called a distance. That is the full description of distance. Example, this is a point A. Starting from this point, coming back to this point, this is another point B. Starting from this point, come back to this point, you travel a distance. You traveled a distance. The magnitude, that means the size of this distance, is the measure. How many centimeters or how many meters from a point A to point B. That's what is called a distance. Now, getting back to the other part, which is displacement. By mere pronunciation, it's somehow different, but they all use the same letter D, I, and S. Well, this one goes straight distance, but the other one goes somehow diverted as displacement. To displace. Once you hear the word displacement, it means a distance traveled in a specified direction. A distance traveled in a specific direction is what is called a displacement. They have a little similarities in symbol. The symbol of displacement is the same thing as the symbol of distance, which we always use the letter S to represent a displacement or a distance. They all have the same unit, which is meter. The SI unit of displacement is also the same thing with the SI unit of distance, which is meter everywhere. In America, in London, UK, wherever you think somebody will make a distance description, he will always tell you that meter is the SI unit of distance. We can have sub-units like centimeters, kilometers, a lot, gigameters, and so on and so forth. But the system international unit, the SI unit, is meter. Displacement has both magnitude and direction. Why? Because it is a vector quantity. Displacement is a vector quantity. It has both magnitude and direction. Example of displacement: I travel 20 kilometers north side of Kano. Or I travel 50 meters west of Abuja. By statement, this is how displacement can be described. I made mention of 20 kilometers north of Kano. 20 kilometers is exactly the magnitude of the displacement, while north of Kano signifies or qualifies the distance or the direction of the displacement. I made mention of displacement. I made mention of distance 20 kilometers, and I said north side of Kano. 20 kilometers is the magnitude. North side to the Kano, or north part of the Kano, it's telling us the direction where I traveled. So this is the displacement by statement. By drawing, or let me see, geometrical representation. This is a point, a cardinal point north, south, west, and east. To demonstrate a displacement, taking a distance from here to here, another cardinal point here, north, south, west, and east. Directions from this way to this way. Automatically, you know, if I start from here, stopped here, I travel a distance, but that distance has direction. That would change it from distance to displacement. Now, this is an angle, theta. This is an angle theta with the horizontal, but this theta is not the angle that gives us the direction where I moves. So if I want to find my direction within the northeast direction where I travel, we know it is not it already. I goes northeast direction already. So since I travel from northeast direction from the starting point northeast, but we don't know the exact bearing. We don't know the exact bearing. We don't know the exact angle where I move from north side direction. So for us to take our direction, we are going to start counting from the north to where my displacement line is. So that means this very angle will be our angle of direction. So now what we say is just alpha. When you're given theta, to find the alpha, you now say 90 minus theta. Therefore, 90 minus theta will give us our angle of direction, the exact point or the exact angle where we move or where I travel in the northeast direction. So to state our direction, we'll now say what? Direction would be equals to, here it's north. So since it is north, we put north, comma, then we'll now put our alpha, degree, then east. So this is exactly the direction of every displacement. This is what is called a displacement. Now we are going to differentiate distance and displacement equally. Like I said, distance is a scalar quantity while displacement is a vector quantity. Also, distance has only magnitude, no direction, but displacement has both magnitude and direction. I think these are the simple differences they have. These are the simple differences they have. If there are some differences ahead, you can further the investigation again, but this is what I can offer for you now, not because I don't know more. That is it. So the similarities they have is like distance and displacement have the same symbol, have the same unit, and they all have the same. No, these are the things they have in common. These are the things they have in common. Yeah, they have this. They have dimension in common. The dimension of distance and displacement is always capital L enclosed in curly bracket. So this is how the the dimension of the both the two quantities have. They have similarities. They have differences, but their differences is more crucial, is more big than their similarities. So this is what I can say about distance and displacement. But in my title above there, I said distance and displacement time graph. Distance and displacement time graph. Distance and displacement time graph are very, very, very important when it comes to calculations under speed and velocity. Speed and velocity. Speed is a quantity derived by the use of distance and time. Once a distance change together with the time, it gives you a speed. it gives a speed. There's a definition of speed is distance traveled in a certain time, or the change of distance over the change of time give you a speed with a formula. V equals to distance change over distance time. Automatically, when you have S1 starting point 0 and S2 is maximum, you now have T1 equals 0 as starting point initial T, then T2 equals to maximum T, maximum time taken. Automatically our velocity will be S2 minus S1 over T2 minus T1. So automatically we are going to have our speed to be equals to since S1 is 0, automatically we have S2. Since our T1 is 0 also, we automatically have T2. So since it is T here and T and S and T all with the 2, we now have V to be equal to distance traveled over time. This is the formula for speed. This is the formula for speed. Now getting back to the displacement, where we use displacement is when it comes to defining velocity. We define velocity by the use of displacement. Like I said, displacement is used to drive velocity. Velocity can simply be defined at the change of displacement together with the change of time, or at the rate of change of displacement with time. So you see one of the differences between distance and displacement. Distance is used to define speed, while displacement is used to define velocity. But velocity and speed, they are almost the same, but they have a little differences, just like the way distance and displacement differ. So now our velocity equals to also displacement over time. You see, our velocity v is this, then speed also. Speed as v equals to distance over time. They all have the same symbol, the same formula, but in statement, that's where they differ. When it comes to calculations also, they are two different things. So they all have the same formula. Now the SI unit of speed and velocity is meters per second. In some textbook it is m s raised power minus 1. Meters per second is the SI unit of velocity and speed. Now we can calculate our speed using a distance time graph. A distance in meter over time in second. So distance time graph is a graph of distance on the vertical axis while time in the horizontal axis. So automatically this is what we have as distance time graph. So these are as a straight line graph with this place to be a uniform speed. So this line as a uniform speed for distance time graph. When it goes straight, we call it a constant speed. Then coming down here